Lesson 83, we're going to talk about vector addition. And the first method it gives two methods. Let's see if you can see that. Yeah, parallelogram and head to tail method. Now those sound fancy, but this is, it might be one of the easiest lessons in the book. So in example 1, it gives vector A of 2, 3. So I drew it out. Remember, just think of it starting at the origin. A vector has a distance to it. So 2, 3, boom, there. B is 4, 1, so over 4, down 1. There's vector B. And it wants us to use the parallelogram method to solve. And literally all you do is you take your two vectors of 2, 3 and 4, negative 1, and you add them together. So I add my x coordinates in a sense. 6, well, 3 minus 1 is 2. So my resultant vector, okay, or my resultant vector here is 6, 2. So when I draw that, over 6 up 2, okay, you can see that's kind of the diagonal of the resultant parallelogram. And that's literally it. It's easy. You just add the two vectors. Head to tail, if it asks you to do that, you're just adding the two vectors again. And you can see that in example 2. But we'll skip that one because it's that easy. Example 3, try to get it with no glare. Okay. Example 3 says find the magnitude. Sorry, get this right. Find the magnitude and resultant vector. So, if I was going to find the magnitude and resultant vector, well, I'm going to show you this by drawing a triangle. Okay, imagine we're, boom, at 0, 0. And vector A is 6, 0. There's 6, okay, vector A. Vector B is 0, 4. Okay, there's A, there's B. Well, all I'm going to do is connect these, okay? Let me make sure I drew that right. 1 second. Yes. Okay. Well, okay, my bad. One thing I messed up on here. We're using the head to tail method here. So this is a good example of how we would use it. Head to tail method means, okay, we're starting from the origin, okay, in a sense, and we're going over 6, 0, so there's vector A. Well, what head to tail method is, if we go from here, okay, this is the end of vector A, and we start from this point and go up 4. So in a sense, think of you're just drawing and not lifting your hand. And then we're going to create our triangle there. And all this line is the sum of these two. So when we add both A and vector B, we get 6, 4 as the sum of vector A plus vector B. Notice this coordinate here is 1, 2, 3, 4, 5, 6, 4. So this line is the sum of my two vectors. Okay? Very simple. Hopefully you didn't get lost there. This line, the hypotenuse, is the sum of my two vectors. Now, in order to figure out, so magnitude means it wants a specific length. Right now it gives us 6, 0. That's not a length, that's a vector. So we need to draw this triangle, and we know since this is 6, 0, 6 is our length. 4 is the height. The magnitude is the hypotenuse here. And to solve for that, we just use Pythag. So 4 squared plus 6 squared equals c squared. 16 plus 36 is 52. Square root of 52, check what that is in my calculator. It's roughly 7.21 units. So there's our magnitude. Now it wants to find the resultant vector. What the resultant vector is, find the angle that the resultant vector is. The angle that we're looking for is the one that connects the horizontal with the hypotenuse. In a sense, it's your angle of elevation. So this is the angle of the resultant vector that we're looking for. So in order to find that, we just apply the trigonometry that we've previously used. This one uses opposite and adjacent. So that would be tangent of theta equals opposite 4 over 6. Plug that into our calculator. Second tangent, 4 divided by 6. And we get roughly 34 degrees. And that would be our angle of resultant vector. So those two things, I think I just wrote that problem wrong. Those two things are what you're looking for, and that would be your answer. Not too difficult, just applying the math principles that we've already used.